All right, so yesterday we talked about simplifying radicals using the product rule. Today, we're just going to be adding on to that a little bit, moving on to multiplying and dividing radicals, but it's going to end up being very similar to what we did yesterday. So first with multiplying, it says if a and b are non-negative numbers, then we can use the product rule, which is what we used yesterday to simplify. So again, this is saying if we have the square root of some number times the square root of another number, we can combine those together and do the multiplication under one square root. So the square root of a times the square root of b is the same as saying the square root of a times b. Once you do this multiplication, then you always have to check to see if you can simplify if possible. Always simplify like what we did yesterday, if possible. They are quick. Always simplify if possible. Just like fractions, how you always check to see if you can simplify. Same thing with radicals. All right, so example 1, we're told to simplify, so we're going to use our product rule. When we have numbers outside of square roots and numbers inside of square roots, we multiply them separately. So we have 2 times square root of 2 times 3 times square root of 5. We can take our numbers out in front, the 2 and the 3, and multiply them together. And then we take the numbers inside the square root and use our product rule to multiply them under one square root. I'll show you. Stay tuned. Okay, so numbers out in front get multiplied together, numbers inside get multiplied together. So we can do that multiplication. So out in front, 2 times 3 gives us 6. And then inside the square root, 2 times 5 gives us 10. And again, if you want to write this multiplication sign in between the 6 and the square root of 10, that's fine. You okay, Taylor? Good? Okay. What? Okay. If you want to write the multiplication sign, you can, but you don't have to. Now, once we get to this point, we need to take a look at our square root, and we need to double check. Can we evaluate it? That's where you check it in your calculator. Do the second x squared, and then 10. Can you evaluate square root of 10? Is it a nice number? No. So then we just need to double check, can a perfect square go into 10 nicely? No. So remember, our perfect squares are 4, 9, 16, 25, 36, 49, etc. All those numbers. Okay? So those are the ones we're looking at. So since we can't evaluate it and no perfect squares can go into it, then that means we are done. And 6 times the square root of 10 is our final answer. Okay, this is very similar to what we did yesterday. We just have to do a little bit of multiplication first. Any questions on letter A? Okay, let's take a look at letter B. So square root of 5 times square root of 6. For this one, there's no numbers out in front, so we don't have to worry about doing that multiplication. We can just go straight to doing the product rule. So we can combine them of the square root of 5 times 6. Which will give us a square root of 30. Okay, and now we need to check. We ask our 2 questions. First, can we evaluate it? If you use square root of 30 in your calculator, does it give you a nice number? Not really. If you look at our perfect squares, can any perfect squares go into 30 nicely? No, so that is it. Yeah. Huh? All right, can you guys try letter C?
No.
Yes, you can.
I already tried to try it.
Try letter C, and always remember to simplify if you can. Letter C, with this one, our first term there, 4 square root of 7, that has, oh my gosh, don't die. We have a 4 out in front, but our second term, there's no number out in front, but if there's no number written, it's always an implied 1. So really this is saying 4 square root of 7 times 1 square root of 7, if that helps you to see that 1 there. So then we can do our multiplication on the outside. 4 times 1 is just 4. And then in our square root, we'll have the square root of 7 times 7. And what is 7 times 7? 49, so the square root of 49. And then we check. So in our calculator, square root of 49, is it a nice number? Yes, what is it? 7, just 7. So it's 4 times 7. There's no square root on the 7. When you did it in your calculator, no square root popped up around the 7. It was just 7. So then we can just do that multiplication. 4 times 7 gives us 28. Okay, any questions here? So let's just do some multiplication and then simplify like we did yesterday. Okay, so moving on then to dividing. We can use the quotient rule, which is very similar to the product rule. It's just dividing instead of multiplying. If we have a and b are non-negative numbers and b is not equal to 0, then if we have the square root of a number divided by the square root of another number, square root of a divided by the square root of b, that's the same as doing that division under one big square root, the square root of a divided by b. And then, as always, double check, make sure you simplify if possible. Alright, so same idea, just dividing instead of multiplying. So if we look at example 2a, we have square root of 75 divided by square root of 3. So using our quotient rule, we can rewrite that as the square root of 75 divided by 3, all under one square root. Make sure that your square root is big enough to fit the fraction. Make sure it's obvious that that fraction is underneath that square root. You don't want to write it like this, because that means something different. So make sure that you're being clear where that square root belongs. And then we can do our division. So 75 divided by 3 is 25. So square root of 25. And then we check, can we evaluate square root of 25? Yes, it gives you 5. And that means we're done. Nothing else you can do there. Let's take a look at letter B. Square root of 90 divided by square root of 2. We use our quotient rule to rewrite that as the square root of 90 divided by 2, all in one square root. Then we do that division, and we get the square root of 45. Can we evaluate the square root of 45? No. Are there any perfect squares that can go into 45? 9. How many times? 5 times. So we can split this up as a square root of 9 times 5. Then we use our product rule like we did yesterday. We can write this as 2 square roots, square root of 9 times the square root of 5. And now we look at each square root separately. Again, this is what we did yesterday. So square root of 9, can we evaluate it? Yeah. Yes, what is the square root of 9? 3. With no square root, it's just a plain old 3. What about square root of 5? Can we evaluate that? No. Can any perfect squares go into 5? No, so we're stuck with it. So 3 square root of 5 would be our final answer. Okay. Any questions there? Again, very similar to what we did yesterday. We're just adding on one little step at the beginning where you're dividing or multiplying. Can you guys try C? Okay, so C, if you do the quotient rule and you do that division, you ended up with the square root of what?
2.
What? Square root of 4. And then what is the square root of 4 equal to? 2. All right. Any questions? Okay. On the back, one last thing. Sometimes when we are dealing with fractions and radicals, we may end up with a radical in the denominator of a fraction as our final answer. The mathematicians do not like that, so they decided to come up with something called rationalizing the denominator, which makes your fraction look a little nicer, and no square roots will be in the denominator. So to rationalize the denominator, and you do need to remember what it's called. You need to remember rationalizing the denominator. So on a test, if I ask you to rationalize the denominator, you have to know what that means. And basically, if the denominator contains a square root of a natural number that's not perfect, meaning you couldn't evaluate it and you still had that square root down there, then we're going to use the fact that when we take the square root of a number times the square root of that same number, it just equals that number. Which, saying it like that makes it not sound like a thing, so I'm going to show you an example. So if we had like the square root of 3 times the square root of 3. We could use our product rule and say that's the same as the square root of what if we multiply? What's 3 times 3? 9. Square root of 9. And what is the square root of 9? 3. So see, when both of the numbers under the square root that you're multiplying are the same, that'll end up being your answer without the square root. So that we're going to use that fact to help us rationalize the denominator. And so we are going to multiply the numerator and denominator, because whatever you do to the bottom, you have to do to the top. So you'll multiply the numerator and the denominator by whatever the square root is in the denominator. It's one sentence. Okay. Once you do that multiplication, as always, you will simplify if possible. Okay, let's do an example. Example 3. Again, the directions: rationalize the denominator, and then don't forget to simplify. So we have letter A, 15 divided by the square root of 6. So right now we have a square root in the denominator. Can we evaluate square root of 6? If we type it in the calculator, do we get a nice number? No. So that means we have to use that rule up here, this fact that the square root of A times the square root of A equals A, to rationalize this denominator. So what is the square root in the denominator? Square root of 6. That's what you're going to multiply in the numerator and the denominator. Okay. So now in our numerator, 15 is not in a square root. 6 is in a square root. Can we multiply 15 and 6 together? No, that square root is protecting that 6. You can't get to it. So we're left with just 15 square root of 6 in our numerator. And now in our denominator, we have the rule. Square root of 6 times square root of 6 would be the square root of 36, which is what? 6. So we'll have 6 as the denominator. Now with simplifying, we can first look at our square root. It's still just the square root of 6. Can we evaluate it? No, it's the same thing. We couldn't evaluate it earlier. Can any perfect squares go into 6?
But you gotta divide by 3 yourself.
Hang on, I'm getting there. Spoiler alert. No perfect squares can go into 6, so now we look at our numbers outside of the square root. So this 15 and the 6 here, is there any number that can go into 15 and 6? 3. So you can either just divide them both by 3, or if you do 15 divided by 6 in your calculator, do the math, enter, enter. It will do all of that for you. Or you can just divide by 3. Divide by 3. You do not divide the square root of 6 by 3. The square root protects that 6 from anything happening to it. Only the numbers outside get divided. So you'll have 5 square root of 6 over 2. Okay, so when you're simplifying, when you have numbers inside and outside of the parentheses, they're two separate things. You can't do them together. And that would be your final answer. Okay, let's take a look at letter B. So we have right now square root of 35 divided by 10. Can we divide 35 and 10 nicely? No, but we could reduce the fraction and make our numbers a little more manageable. So you can do 35 divided by 10 in your calculator, and do the math, enter, enter. And what is our reduced fraction? Yeah, 7 halves, but okay. So square root of 7 divided by 2. Okay, it just makes the numbers a little smaller, a little more manageable to work with. Now we can use our quotient rule, split this up into 2 separate square roots. So square root of 7 divided by square root of 2. Because there's no more simplifying we can do with the 7 halves. It's just going to give us a decimal no matter how hard we try. And now in our denominator we have a square root of 2. Can we evaluate the square root of 2? Can we evaluate the square root of 2?
No.
No. Can any perfect squares go into 2? No. So that means in order to get rid of it, we have to rationalize the denominator. So whatever the square root is in the denominator, that's what you multiply by. So square root of 2 gets multiplied in the numerator and the denominator. And now when we do this multiplication, in our numerator, square root of 7 times square root of 2, both of those are in square roots, so we can multiply them together. Square root of 14. And then in our denominator, square root of 2 times square root of 2 would end up giving us square root of 4, which is 2. Nope, not square root of 2, just 2.
Just regular 2.
So square root of 14 in our numerator divided by 2. Bless you.
Bless you.
Make sure that when you're writing this, it's obvious that only the 14 is in the square root. This 2 is not in the square root, right? We got rid of the square root when we did this rationalizing here. So make sure that only the numerator is in the square root. Can I divide 14 and 2? No, this is in a square root, and this is not. Can't do that. Square roots protect numbers. You can only do stuff if everything's in a square root or if everything's not in a square root. So that means this is our final answer. Okay, you cannot divide or multiply if one number is inside a square root and the other number is outside of a square root. Okay, any questions? Okay, let's do this last one here.
I got a question real quick.
Sure.
So, when you start this, when you start C,
Mm-hmm.
do you divide by 6?
Yeah, you can.
That's what you start on?
Yeah, so with simplifying, it doesn't really matter when you simplify. At some point, you're going to have to do it if you want to do it first, and then do the multiplying and rationalizing. That's fine. If you want to do the rationalizing first and then simplify, that's fine. It's kind of a personal preference. But yes, as Darnell said, right now we have this 12 and the 2 that are both not in the square root, so that's how we're able to deal with them together. Can we simplify 12 divided by 2? Yes, what is 12 divided by 2? 6. So this is the same as saying 6 over square root of 8. Okay, and so now if we look at our square root in the denominator here, can we evaluate square root of 8? No. Can any perfect squares go into 8? Yes. What perfect square can go into 8? 4. So we can have 6 over the square root of 4 times 2. And we could use our product rule to split that up. And what's the square root of 4? 2. So 6 divided by 2, square root 2. And now again we have the 6 and the 2 that are both outside of the square root. Can we simplify 6 divided by 2? Yes, we get 3. So 3 over square root of 2. But now we have to rationalize the denominator because we can't evaluate square root of 2 and there's no perfect squares that can go into 2. So since square root of 2 is in the denominator, that's what we're going to multiply in the numerator and the denominator. So in the numerator, can I have square root of 6?
No.
No, because 3 is not in a square root, 2 is in a square root, so you got to keep them separate. 3 square root of 2. And our denominator, if we have square root of 2 times the square root of 2, what will that give us? Well, it'll be square root of 4, which is 2. Can I do 2 divided by 2?
No, ma'am.
No, because this is in a square root, and that one is not, so you have to leave it. Can we simplify the 3 and the 2, though? Those are both outside. Can we do anything with those? No, that's as reduced as far as you can, so this is our final answer. Okay. Questions on C? Can you guys try D? So you're first going to want to use the quotient rule to split it up into 2 square roots. The square root of 2 divided by the square root of 3. And then you can do your rationalizing and simplifying. Okay, so for letter D, once you split it up like this, what did you guys multiply in order to rationalize the denominator?
3 times 3.
Square root of 3, you mean?
Yeah.
Yes.
And then I got 6.
Square root of 6, you mean?
And I got 9.
Square root of 9, you mean? What's the square root of 9 equal to, though?
3.
3.
So 6.
Square root of 6 divided by 3. Shh, darn out, please. Can I do 6 divided by 3?
No.
No, because the 6 is in a square root and the 3 is not. So you got to leave them separate. But looking at a square root of 6, can we evaluate the square root of 6? No. Can any perfect squares go into 6? No. Okay, so we're done for real. Okay, you guys have any questions? It's really just some more simplifying stuff like yesterday.